Welcome to ChemPlus. Welcome to ChemPlus. Today we've decided to make a standard solution of sodium hydrogen carbonate. What equipment we need? Let's go. We are going to need a 250 ml volumetric flask. We are going to need a balance. We are going to need a weighing board. We are going to need a beaker. We are going to need distilled water. And we are going to need a glass rod. A standard solution is one whose concentration is known. We should not lose sight of that. A standard solution is one whose concentration is known exactly.
Today we're going to learn about making a standard solution, right? We're making a standard solution of sodium hydrogen carbonate. There is a sodium hydrogen carbonate. What are we going to do? We're going to weigh exactly what we need. We need a weighing board. We need a balance. We need a weighing board. You take the mass of the weighing board. You record it down. Is that okay? You record it down. Now you take a spatula. Where are the spatulas? You take a spatula and you take a sodium hydrogen carbonate from the bottle and you put your sodium hydrogen carbonate, and we are aiming at between 2 and 2.4 grams, right? Once you know the mass of your board and the sodium hydrogen carbonate and the mass of the empty board, you should be able to work out the mass of the sodium hydrogen carbonate that you've added. Once you've done that, you are going to take the sodium hydrogen carbonate, which is in there. You want to put it in this beaker here, right? So you can actually scoop it down using your spatula. Scoop it down, scoop it in, scoop it in, scoop it in. But what's going to happen is some of the solid will remain here. You take your distilled water, you wash all of it into the beaker, right? You wash all the solid into the beaker. You can even add more water into the beaker. If you want to use a stirrer, you can use a stirrer. But if you just want to swell it, you can do that. If you use a stirrer, at the end of the day, when you finish stirring, you should wash the solid away from the stirrer into the beaker. Right? That's you done. Now, we need to transfer our solid into the volumetric flask. You get a funnel and you transfer it into the volumetric flask. Be mindful of the fact that some of the solid is left in here. We've got to wash it again. We don't want any solid remaining anywhere. So what we do is we wash it in. There you go. You can wash as many times as you want. 3 times will be enough. After that, wash the funnel again. Wash your funnel. Right? Then after that, the volumetric flask has got a line here. That's where the 250 mark is. You will see it, you won't miss it. Fill up the volumetric flask to that mark with distilled water. So you fill it up there with distilled water. And the very last thing, when it's on 250, you are going to get a lid. Someone does it very carefully, the groups. You mix as many times as you can. If you want to really, you can. Right? Now, you know how much solid is in there, you know the volume, you can work out the concentration. I'll give you a label. You write the name of your class and the initials from one of your group members, and then we can use this for the titration next lesson.
When you measure the volume in your volumetric flask, you should make sure that your distilled water gets to the to that line there. That's where the 250 mark is. And you should measure the volume of liquids at the meniscus. This is the meniscus, and you aim to measure from the bottom of the meniscus. A standard solution is one whose concentration is known. So that's the purpose of this practical. We are going to work out the concentration of sodium hydrogen carbonate. Now then, when I've carried out this experiment with one of my classes, their mass of the board was 0.55, mass of pot plus solid was 2.55 grams. Therefore, we can work out the mass of the solid, which was 2 grams. Let's go. How do we work out the concentration of the sodium hydrogen carbonate? To begin with, let's work out the MR of the sodium hydrogen carbonate. Let's work out the MR, which is sodium plus hydrogen plus carbon plus 3 oxygens, and that gives us 84. That's the MR. Now, the next big thing that we want to do is to work out the number of moles of sodium hydrogen carbonate. Sodium hydrogen carbonate is equal to mass over Mr, which is equal to 2 grams divided by 84. You need your calculator. 2 divided by 84, and you get 0.0238. It's a long number going. It's a long number. Don't make those. The moles are at the bottom there going. It's a long number going. Now that we have the moles, we can now work out the concentration. We know that moles is equal to C times V over 1,000. Therefore, concentration, I want to pick a bigger. Therefore, concentration is equal to moles divided by volume over 1,000. Now, which is equal to, your moles is 0.0238. 0.0238 divide by volume, which is 250. That's our volume over 1,000. Now you got to punch that in now. My handwriting there is not really good. That's 238 there. Let me pick a better pen. 238. So when I've divided that, I am getting 0.0238 divided by open brackets 250 divided by 1,000. I am getting 0.0952 mole decimeter, which means our concentration for this solution is 0.095 mole decimeter. A standard solution is one whose concentration is known exactly. Now we know the concentration of this sodium hydrogen carbonate. We know the concentration of this sodium hydrogen carbonate. You should be able to do this practical in the lab without any big problems, right? We hope you've learned a bit on making standard solutions. Signing out from inside the cup. King of the classroom. Bye bye.